In this video, we derived the steady flow energy equations for a compressor. First, we understand what is the functions of compressors. Then after, we derived the steady flow energy equations for the two types of compressor, that is the centrifugal compressors and reciprocating compressor. Compressor is a device used to increase the pressure of air or a gas. Okay, so that is the various applications of the compressed air or a gas. Okay, so compressed air is used for the automobile industries, means we are filling the compressed air in our tires. It is used for the painting, means for the coloring of the homes and the various applications. In a pneumatic system, various types of, so that is a number of applications for the compressors. So generally you see the compressors at the tire repairing shop. Okay, that is for in car accessories or a garage shops. That is generally used to fill the air in our tires of various vehicles. So first we understand about the rotary compressor. So here you see these diagrams of the compressors. So in a compressors we need to supply the mechanical energy. Okay, so for convert the electricity, means electrical energy into mechanical energy, we require the motors. Okay, so in a motor we supply electricity, it is converted into the mechanical energy, means this shaft is rotated, it is called mechanical energy, and this shaft of the motor is connected with the shaft of the compressor. Okay, so here you see this is the compressor. Okay, here it is the inlet of the compressor, here the air is in, and here the air outlet is there, means high pressure air or a gas is out from these portions. So here we give the section A, inlet parts, outlet part is the section 2. Okay, and here you see that we need to supply some work done, and when we know that when we supply the work done to any systems, it is considered as the negative, means when we solve the examples of the compressor and we get the W as a negative answers, because we are supplying the some work to the compressors. We know that steady flow energy equation means general steady flow energy equations that we already derived. Okay, so for starting the derivations of the any component or any systems, we require the basic generalized equations, and it is the M in bracket h1 plus c1 square by 2 plus z1g bracket over plus q is equal to M in another bracket h2 plus c2 square by 2 plus z2g bracket over plus work done. Now we need to consider the certain parameters for the rotary compressor. So first Z1 is equal to Z2, means Z1 minus Z2 is 0, generally taken. Okay, here we suppose we take the bottom of our skin, then Z1 and Z2 are different, but we consider they are nearly equals. Okay, means Z1 and Z2 are same. Then we putting this value on this above equation, then Z1g and Z2g's are cancels from the equations. Second is C1, means velocity at the inlet is nearly equal to the velocity at the outlet, means change in the velocity is negligible, change of kinetic energy is 0, means C1 square by 2 and the C2 square by 2 are equals. Okay, so these are the basic considerations, but in during the calculations of the numericals, suppose the C1 and C2 are given different. Okay, so it is also possible, but these parameters we are assume. Q is nearly equal to 0, heat transfer is negligible since the compressor is thermally insulated. If this compressor is thermally insulated, then no heat transfer to or from the system. Work done does not equal to 0. We know that we need to supply some work done. That means the value of the work done does not equal to 0. Shaft work done by the system, so W is the negative. Why it is negative? We supplied the work done, that we already discussed. Now we putting this all this value in this steady flow energy equations, and what we get on the left side only remaining parameter is the MH1. Because C1 and C2 are same, so this step is cancelled. Z1 and Z2 are same, this parameter is cancelled. Heat rejections or heat supply is 0, Q is equal to 0 because the compressor is insulated. So left side only remaining part is the MH1. Okay, then after equal to on the right sides, that C1 C2 is same, so this step is cancelled. Z1 Z2 same, this step is cancelled. So only remaining part is the MH2 plus W. Okay, now suppose we need to calculate what amount of the work done required to compress the air. Okay, then we can calculate. So this MH2 is supplied on the left side, so it is the MH1 minus MH2. Okay, so W is equal to M in bracket H1 minus H2. Okay, now which one is the higher? H1 is higher or H2 is higher? So we know that suppose we have the 5 rupees and we add the 10 rupees on our pocket, then which our pocket value is increased, that is the 15 rupees. Okay, so same way, suppose the H1 is some value, that is suppose the 5. Okay, and we supplied the 10 work. Okay, then outlet enthalpy is the increase, that is a 15. Okay, so inlet enthalpy is 5. By supplying the some work done, enthalpy is increased to the 10, so it is a 5 plus 10, 15. So outlet is always higher. In a turbine, what happen? We get the work done from the steam or a gas, so enthalpy is reduced at the outlet. So here H2 is greater than H1. Okay, so here the H1 minus H2. So value of the H2 is higher, then what is the meaning? Work done is negative. Why it is negative? Because we supplied the work done that we already studied in chapter number 1. Now next we move towards the reciprocating compressors. Before moving ahead, I request to like the video and subscribe my channels for watching the more video related to engineering thermodynamics and another subject of the mechanical engineering. For the engineering thermodynamic, various link is provided in descriptions as well as on the card. Card means on the top right screen of your mobile or laptop you see the I symbols. And for other subject I request to visit the playlist. Now second type is the reciprocating compressors. So on this diagram you see that the component inside the compressor have the reciprocating motion, means we use the cylinder, inside the cylinder piston, and the pistons are reciprocate. That's why it is called as the reciprocating compressor. Here the air inlet, it have the section 1. Here the high pressure air outlet, it have the section 2. And these pistons are reciprocates, and the piston is connected with connecting rod, crank, and the shaft of the crank is connected with the motor. So we know that the steady flow energy equations, that is M in bracket H1 plus C1 square by 2 plus Z1G bracket over plus Q equal to M in another bracket H2 plus C2 square by 2 plus Z2G bracket over plus work done. For reciprocating compressor, we consider the same parameters Z1 and Z2 are nearly equal. So potential energy is 0. So this Z1G and Z2G are cancelled from the steady flow energy equations. Second is C1 is nearly equal to the C2, means change in the kinetic energy is 0. Change in velocity is negligible. Change in kinetic energy is 0, means C1 and C2 are same. So this C1 square by 2 and the C2 square by 2 are cancelled. Q does not equal to 0, means appreciable heat transfer is involved. Heat is rejected from the system and Q is negative. So in reciprocating compressor, what we consider that Q amount of the heat is transferred to the surrounding, means they are rejecting. Okay, so we are not considered a Q is equal to 0. Work done does not equal to 0. Shaft work is done on the system and the fluid is compressed. So W is negative. Why W is negative? We supplied the work. It is same as that earlier. Hence, now we putting this value on these above equations. Okay, so remaining part on the left side is the MH1. This C1 is cancelled. Okay, Z1G is cancelled. Q is not cancelled because it's have the some value. So on the left side, MH1 minus Q. Why it is minus Q? Here the plus Q is written. We consider the minus because they transfer the heat to the surrounding, means heat is rejected from the system. At that time we consider the Q is negative. On the right side it is the MH2. C2 is cancelled, Z2 is cancelled, and the work done is remaining. Okay, and we supplied the work done, so it is coming negative. Okay, so work done is equal to M H1 minus H2 minus Q, where H2 is greater than H1, so we received this answer on this negative. Okay, so that we already discussed about the H1 and H2. So thank you for watching this video. If you learned something and like the video, subscribe the channels and don't forget to share with your friend.